Consider two beams with equal cross-sections made of the same material having the same support conditions and each loaded with equal uniform load per length. One beam is twice as long as the other. The maximum bending stress in the longer beam is larger by a factor of dash. So let's see how we can solve this problem. So by dash. Let me read the question again just to make sure that I myself understand it. Consider two beams, okay, with equal cross section. So let's say one beam is this and another beam is way too long. It's not that scribble the way I draw it. Let me draw a more straight line. So one is there and the other one is, let's say the other one is twice. That's what it says, right? They just say two beams for now. Alright, so made of the same material, having the same support conditions. Let's say they have the same support conditions. Let's say, let me put a roller or maybe a pin first. Let me put a pin and a roller over here. So that is there. And on the same side too, they have the same thing. A pin and a roller. Oops. Okay, right. Okay, so those are the two beams, and each loaded with equal uniform load per length. So equal uniform load. Equal uniform. Oops. Uniform load. Don't mind my handwriting, please. I'm a little bit too fast. So let me erase this a little bit. Okay, all the way. Yes, that's better. And this also like that, like that, like that, like that. Okay, so I think that's what the question is asking for. So let me change to black pen. One beam is twice as long as the other. So this is, let's say this is 2L. And this is just L, the length. So the maximum bending stress in the longer beam is larger by a factor of what? So let's say, I hope you guys still remember your, I think this is statics analysis or deformable body or mechanics of materials. If you have taken any of these theory classes, they should be sounding refreshed in your brain, because when they say the maximum bending stress, that just means sigma. Sigma is what we use to designate maximum bending stress. So sigma equals to MC, and M stands for moment. C is where the neutral axis occur, over MC over I. So please don't forget that. I think most of you guys probably should remember this. And if you don't remember, it's in your SAM book. The book that you can bring into the class, to the exam, is called SAM. CERM, SAM book. You can bring it in. And actually, I'll be honest with you guys, you can bring anything into the exam. As long as it's a binder, folder, they don't care. You can print these questions that I'm uploading online. You can print it out. As long as it's in a binder, they don't care. As long as you bring anything in, they don't worry about it. There's no limit to what materials you can bring into the exam. So anyway, so sigma equals MC over I. So what is moment for uniform distributed load? Moment is, let me write everything together. Let me just separate it. M for uniform distributed load is W L squared over 8. And you don't have to remember that equation too. It's at the back of your book, appendix, in the sum book. You can look it up. But if you know it, on top of your head, it's going to save you time on the exam. So now plug this equation back into M over there. And before we actually do that too, let me just say I also. Let's say we're dealing with a rectangular beam. So I for rectangular is BH cubic over 12. Okay, the rest of the stuff is just like plugging into the original formula. So if you plug in everything in, we should come up with, let's see, let me M first, W L squared, everything over 8. And if you do, and times C, if a rectangle is basically, that's like B over 2, if I'm not mistaken. Yeah, that's B over 2. So let me just write that as C for now, and now divide everything by I, which is BH cubic over 12. Okay, if you flip and flip, just rearrange stuff, you're gonna come up with W L squared BH cubic C over 8 times 12. Okay, remember what the question says. The question says everything is uniform except for the length. The length is the only thing that changed. The rest of the materials remain the same. So, hey, look, they're telling you what it is. And C in this case is H over 2 for the neutral axis. So, W is going to be the same for both. You can cancel it out. B is going to be the same. Let me use a red pen so you guys can see better. Red pen. W cancel out. B cancel out. H cancel out. C cancel out. The only thing that, and literally 8 times 12, the number will cancel out from both of the side of the beam was. So the only thing that you have left in the equation, it will be L squared. L squared. That's the only thing that you have left. And if you don't remember they said the only thing that changed, if you read the question carefully, that one, let me see where it says that one beam, let me highlight that. That's the only thing that changed. One beam is twice as long as the other. That's the only thing that changed. Everything else remained the same. So in this case it's L squared. So in the first one, we're gonna have the same thing as L squared. The segment will be L squared in the first beam. So, and the second beam would just be L times, just plug 2L into the L. So if you plug in 2L squared. Let me write 2 properly. And that should give you 4L squared. 4L squared. In that case, your answer will be D. So the long beam is 4 times the shorter beam. Alright, see you guys in the next question.